In real-life applications such as flow over a car or flow over a wind turbine rotor, we have complex flow domains, and when we mesh these flow domains, we are going to get irregular meshes. It turns out that the finite volume method can be extended to deal with irregular meshes, and this is an advantage it shares with the finite element method. And the cells can be any type of polygon in 2D. When we do the flow over an airfoil in Fluent, we are going to have a mesh that looks like that, and this is a combination of quadrilaterals and triangles. So for instance, you have a quadrilateral here. Here's a quadrilateral. Here's a triangle. And we are going to solve for the values of pressure and velocity at the centers of these cells, similar as before. In 3D, the cells can be any type of polyhedron. So one could have, one typically has tetrahedrals, hexahedrals, or prisms. And whatever the shape of the cell, we would calculate the fluxes passing through each face, and we would calculate the forces on each face. So you do face by face, as we talked about in our simple example. For instance, to do the mass conservation over the cell, we would calculate the mass crossing this face, this face, this face, this face, and add that and set that equal to 0. And to calculate the mass crossing that face, we would interpolate between, say, the value here and the value at the neighboring cell center. This can be done in a couple of different ways. This would be called central differencing, and this is one way to do it in the interpolation. So we would use neighboring cell center values to get the face values, which is what we did in our simple example. And the extension to irregular meshes, conceptually, though it's straightforward, the details are very complex, and there's a lot of bookkeeping involved. But this is where it's great to have a powerful solver like ANSYS Fluent. So we will let the solver take care of the details, and so we won't get bogged down in the details. And with this level of understanding of the big ideas, we can go forth and solve exciting flow applications.